section 1.4.1, we want to now merge different images into a single image. So we have this 3 images, band 4 image, band 3 image, and band 2 image. Let's put them into a single file. We've already seen the use of GDAL build VRT. We can create a VRT file and say, I want to create a single file with 3 bands, red, green, and blue. Now, if you just use GDAL build VRT with this default option, it'll say, oh, I'm going to create a mosaic of this. I'm going to create a single file. I will assume the files are all spatially at different places, and I'm going to create a mosaic. But if you look at these files, they are all at the same place. They are just overlapping images. They are images of the same area in different wavelengths. So GDAL build VRT has this option called separate. Separate says, oh, they are the same image for the same region, put them in different bands. Instead of mosaicing them into a single band, consider that they are bands of the same image and put them in separate bands. So let's run this command. We're going to say GDAL build VRT, create rgb.vrt, and we'll take 4, 3, and 2. So the order is important here. 4, 3, and 2 will say, we'll put the 4 in the red channel, 3 in the green channel, B in the blue channel. And since they correspond to this, we'll get an RGB composite. Just copy this. So from the Lancet folder, we'll run this, and we're going to build the VRT. Let's check the VRT that we created. We'll do rgb.vrt. And now you can see we have created this VRT, which is the same size as the original image, same projection. We have 30-meter resolution, and now we have 3 bands. So we took 3 one-band image, combined them into a single 3-band image. This is also a useful technique where you say, I've got 12 images of precipitation, 1 for each month. How do I put them in a single image with 1 band for each month? So again, you create a VRT file, but use the dash separate option to put them as separate bands instead of a single image with which are spatially distributed. So we have the VRT file. We can take a look at this, but again, this is large file. Instead of doing this, let's just convert the VRT to a TIFF file, and then we can take a look at the resulting file. So we'll use the GDAL translate and take the VRT and convert to TIFF. We can give this option saying that whatever we give, you can see the bands do not have the information defined. What is band 1? We don't know. What is band 2? We don't know. If we give this information, saying photometric RGB, it says, interpret this 3-band image as an RGB image and show it to user as RGB. So we can do this and we can apply some compression. So let's do the next part. So now we're taking the VRT and now creating a new file by stacking these 3 images as 3 separate bands and creating a single image. Let's do GDAL info on the rgb.tiff. And now you can see when I load this GDAL, and now in turn QGIS will know that the first band is red, second is green, third is blue. And we have a 3-band image. Let's load this into QGIS and take a look. This is what this image looks like. You can see now we have some colors. It still doesn't look very pretty. We're going to make changes, but now you can see we have stacked all of the 3 bands and we have the information as an RGB image. If I inspect a pixel value, you can now see I have 3 bands at each pixel, and these are the different pixel values. And you can keep those pixel values. These pixel values have meaning. The reflectance values have a scientific meaning. So you do not want to apply JPEG compression to it. You don't want to mess with these values because they have a scientific meaning. But we want to improve the visual quality.